For the next few minutes, we're going to take a review of the difference between IFR and VFR conditions and how you can tell the difference between IFR and VFR weather conditions using your METAR observation. Before we begin looking at IFR and VFR, we're going to go back and review our METAR decoding. We're going to start with our visibility. In the first example here for KSSC, which is Shaw Air Force Base, we see on the 26th day of the month at 20:55 Zulu, the winds were variable, and the visibility, as indicated in purple, is 7 statute miles. 7 statute miles is also sometimes referred to as unrestricted visibility. In the United States, all of our visibility is reported in statute miles, and when we're outside the United States, in countries that use the metric system, we're going to measure our visibility in meters. In the second observation, also from Shaw Air Force Base, indicated by KSSC, on the 26th at 12:10 Zulu, our winds are 060 at 6 knots, and we see in purple letters that our visibility is 3/4 of a statute mile. We indicate in the observation BR, which stands for mist, that is the weather phenomenon that is reducing the visibility to 3/4 mile, coming down from unrestricted. Anytime you have less than unrestricted visibility, the observation should encode what is causing the visibility to be less than unrestricted. In the third observation from EGUN, or Mildenhall Air Base in England, we note that the letters in purple show that the visibility is unrestricted, as indicated by 9999. Lastly, the LIYW, or Aviano Air Base, visibility, as indicated in purple, is 8,000 meters. And it's haze in this particular case that is bringing the observation down from unrestricted to 8,000 meters. Now looking at sky condition in the METAR observation, we note the position of the sky condition comes after the visibility and after whatever weather phenomena is causing the visibility to be less than unrestricted. In the first METAR from PGUA, we see that with an unrestricted visibility, the sky conditions are few at 2,000, few at 5,000, and broken at 30,000. And as a reminder, to get the numerical value of the height of the clouds in feet, you simply add 2 zeros at the end of the number. Again, as a review of definitions, few clouds are defined as 1 or 2/8 coverage of the sky. Scattered clouds would be 3 or 4/8 coverage of the sky. Broken clouds will be either 5, 6, or 7/8 coverage of the sky. And finally, overcast conditions are 8/8 coverage of the sky, or completely covered. If there are no clouds at all, the code is going to be SKC for sky clear. In the second observation from KLBF, or North Platte, Nebraska, from the 19th day of the month at 20:56 Zulu, we see that after the 10 statute miles visibility, we have the code SKC, or sky clear. In the third observation from Tyndall Air Force Base, or KPAM, we note that with unrestricted visibility, the sky condition is scattered at 1,000 and overcast at 1,600. The scattered at 1,000 deck, remember, is 3 or 4/8 covered. And then the overcast deck at 1,600 is completely covered at 8/8. And then finally, KXXX, we see that with quarter statute mile visibility, as a result of fog, we have a vertical visibility, as coded by VV, of 500 feet. The vertical visibility in this case is the ceiling. So a review of some terms that we'll use. First off, what VFR means. VFR stands for Visual Flight Rules, and it means that the ceiling is greater than or equal to 1,000 feet, and the visibility is greater than or equal to 3 miles. Now, in terms of what a ceiling is, anytime you have a broken or overcast deck, the first broken or overcast deck in the METAR is your ceiling, and we'll go through some examples to point that out. IFR stands for Instrument Flight Rules, and those conditions are when you have less than 1,000 foot ceiling and or 3 miles visibility. IMC is often a term that's used and confused with IFR conditions, but it simply means instrument meteorological conditions, or that the pilot is flying in clouds or in the weather. There is no numerical value of cloud ceiling or visibility associated with IMC. It just means that the pilot is in the weather. It could be at 1,000 feet, it could be at 10,000 feet, but the pilot is in the weather. VMC, on the other hand, stands for visual meteorological conditions, and it's exactly the opposite of instrument meteorological conditions. In this case, the pilot is in virtually clear air or outside of the weather. Again, no height or horizontal visibility is indicated with VMC. So why do we care? If you're a pilot who's flying on a VFR flight plan, which means you are expecting to fly with ceilings greater than or equal to 1,000 feet, or greater than or equal to 3 miles visibility, you need to be able to see that runway while you're on your approach to landing. You have to clear the clouds with enough time to make decisions prior to touchdown. If you're a pilot who's not rated for instruments, if to go IFR, you're going to run into some trouble. In generally speaking, IFR and VFR conditions also help shape decisions on takeoff. Mainly in the event that the pilot has to execute an emergency procedure to come back around and land right after takeoff. He still, again, needs to have enough time after he clears the cloud base, or has enough time based on horizontal visibility to see the runway and make decisions. And then lastly, the pilot, especially if he's not rated to fly on instruments, needs to avoid inadvertent instrument meteorological conditions, otherwise described as flying into a cloud. And those are the points during the flight which may contribute to controlled flight into terrain, or CFIT, which is essentially crashing into the ground. Go into a cloud, you can't see terrain, and you end up flying into the terrain. So in our first example from KONL, which is O'Neill, Nebraska, on the 4th day of the month at 19:55 Zulu, we see this is an automated observation where the winds are calm. The visibility is 10 statute miles. And we have an overcast deck or completely covered sky at 1,000 feet. Now in this particular case, the visibility is well above 3 miles, which would fall into the VFR category. And we also see that with a 1,000 foot overcast deck that our ceiling is at 1,000 feet. And therefore, this observation is a VFR observation because I'm greater than or equal to 1,000 feet and greater than or equal to 3 miles visibility. In our second example from KZZV, which is in eastern Ohio, and the 4th day of the month at 19:53 Zulu, this is once again an automated observation. The winds are 140 or out of the southeast at 5 knots. We see that our visibility is 1/2 statute miles, and it's snow and freezing fog that is reducing our visibility down from unrestricted. Our clouds are being measured at vertical visibility at 1,100 feet. The temperature in this case is -4 Celsius with a dew point of -4 and an altimeter of 29.88. Looking back at the visibility in the ceiling, the visibility is well below 1/2 mile, as indicated here by the half statute mile. And the vertical visibility is at 1,100 feet, which is slightly above the 1,000 foot threshold between IFR and VFR. However, when determining if we're going to have an IFR or VFR METAR observation, we always go with the lowest possible value. So in this case, with 1/2 statute mile visibility bringing the METAR into the IFR category, we say the entire observation, even though the ceiling is higher than 1,000 feet, is actually an IFR condition. Our last example, KGRK from Gray Army Airfield in the central Texas. On the 4th day of the month at 19:55 Zulu, we see that the winds are out of the south, 190 degrees at 9 knots. Our visibility is 7 statute miles. The sky condition is measured at scattered at 3,700 feet. Temperature 23 Celsius, dew point 14, with an altimeter 29.83. In this case here, we have unrestricted visibility, which is obviously well above 3 miles, putting the visibility into a VFR category. And with only scattered clouds, there is no ceiling being reported. I have no broken or overcast deck. Therefore, there is no IFR category or VFR category for the ceiling. With both VFR conditions met for ceiling and visibility, this entire observation will be classified as a VFR observation. So in summary, if your ceiling, which is your broken or overcast deck, and the lowest broken or overcast deck, is less than 1,000 feet, the entire observation is IFR. If the visibility is less than 3 miles, the entire observation is IFR. If both the visibility is greater than or equal to 3 miles, or the ceiling is greater than or equal to 1,000 feet, then the observation is VFR. If both the visibility is greater than 3 miles and there is no cloud ceiling, then the observation is VFR. I hope this cleared up for you a little bit about the difference between IFR and VFR conditions and how you can determine those by looking at your METAR observations.